1.5a part 1. So I'm going to break this up into two sections. Now, this first part is just a review of conics, but the overall concept is this, that we're going to look at convert conics in parametric form. All right, so we're going to go through today and review the three conics and different things that you probably covered in Algebra 2, the focus, the directrix, but you probably only did it for the parabolas, not for the other two. So we're going to break down those components on those three conics, and we'll then take a break, and then we'll come back and do converting from all this into parametric. All right, so the first one is parabola. Okay, in terms of y equals ax squared. So looking at the graph of this, you have a parabola, but with the parabola you have two things here. That we have a value here of the focus and a line that's equal distance, so this is congruent to this, called the directrix, and that's be in form of y equals whatever that distance is, so in this case be negative a, and the focus, actually that would be incorrect yet, I haven't got to that part, but it'll be y equals something, and this focus up here 0, comma some value we call it f. Okay, now so for every parabola you have these two pieces. Okay, now using the Pythagorean theorem, and distances of, and we'll call this here there, and we'll call this P, this is F, so that'll be distance of FP, and the distance here of PI. And basically, by using the Pythagorean theorem and those two distances, and these two distances are always congruent, so this would be congruent to this, and plugging into Pythagorean theorem, you get a distance equation of y equals 1 over 4p x squared. And lo and behold, if you look at that, if this is the distance equation, that means that implies that this has to be the same thing then as y equals ax squared. So that would mean then the distance, and this would be the distance of the foci and the directrix, would imply that that would be then 1 over 4p, and which means that p would have to equal a. Okay, so in this case here, so let's go through it as an example now. If you have y equals 1/8 x squared, that would mean that the distance to my focus is represented by 1 over 4p, which then would mean that this be 1 over 4 times 1/8, which would mean the distance to my focus and directrix is 2 units. Okay, so if we graph this out, And notice my scalar is 1/8, so this is going to be a really flat parabola. That my focus is going to be 2 units up. So 0, 2. There's my focus. And my directrix is going to be y equals -2, since we are starting at 0, 0. Okay. Now, if you don't remember what this all entails from Algebra 2, that would mean that if anything comes down here, like say a satellite wave or something like that, hits this, that this is going to be bouncing off and hitting directly to this center of value here. Or if I threw a tennis ball down here, that tennis ball would bounce and hit that spot. And therefore likewise here, and so on and so on. So anyway, that's kind of where you were taught in Algebra 2 looking for the focus. But there's more, a little bit more to this. There's also something called, so let's make a little note here. There is also a thing called eccentricity. Okay, which basically, of course, it's a huge word for math people. So we got to come up with a letter. So guess what? They start with E. So this is not a printed E. A printed E would be E of 2.7, 1828, 1828, and so on. This is more like a printed E. But it has nothing to do with natural logs. Okay? It actually deals with eccentricity. So what it does is deals with the distance of these two values here. So if you look at, coming back up there, if you have PF, the distance of that, and if you divide it by the distance of PI, which we're going to be using variables of C over A, and I'll talk about that more often here. But right now, for a parabola, the C and A are both equal, so A equals C for a parabola. That would be 2 over 2, so the both distance would be 1. And that is true for any parabola, okay, but not true for other values. Okay. Now for the directrix, another way to get this directrix would be using what C and A are. So, which basically would be A squared over C can also give you that directrix. Now obviously we got A and C by a different way, by 1/4p, but if we just compare here, this would be 2 squared over 2, which is 2. Okay. All right. Now, so you're probably wondering, how is this related to some things of what we're getting into? Well, the parabola, or parabola, can be drawn, and there's a key word there, drawn from the focus, not from an X and Y axis. Okay, or better known as the pole. Okay, so if you come back here, so instead of drawing from here this x-axis and my y-axis, what we need to accomplish here is be able to draw it from one of these points here. And actually, this is going to be our point here. Our focus is actually going to become our pole. So we're going to stand here at this point and look at an object that's, say, traveling along this path, and we're going to be able to track it with that focus, okay, from a single point, not from an X and Y axis. So you can think of it as, say, a radar tower or something like that, watching a plane fly around and monitoring it from a single point versus trying to graph it out on a grid. So that's our ultimate goal here. Okay. One more thing too, just to throw a little humor in here. There's a thing called come back here, a distance across here. That distance is found by of 1 divided by 1/8, which would be 8 units. Now, what they call this is a lattice rectum. So anyway, just for a little laughs, so if you ever ask me to find where your lattice rectum is, you got that one on your own. I'm not going to ask that on any test, but thought you should at least know that there is a unique thing about the distance across through the focus. Okay? So anyway, on to the next piece here. So let's look at another example before we look at ellipses and hyperbolas. So let's say we have x equals 1/2 y squared. Okay? So basically, you're graphing the parabola out sideways. So you have a function like so, which means you're going to have a focus somewhere here and a directrix here. Now this causes problems in rectangular because this is not a function, but our ultimate goal is not worry about function, but be able to stand at a single point and graph as the object moves around here. So it doesn't matter whether it's a function or not. How do we accomplish this? So first off, we got to find the focus. So again, the distance is found by the 1/4p, which would imply then that you have 1/4 times 1/2, which would be a half. So that would mean my focus here would be 1/2, 0. And my directrix here would be x equals -1/2. Okay. Now, my eccentricity, and I usually call it Ika, to try and remember it. So my Ika, or E equals C over A. Now on a parabola, my A and C are the same. So you have 1/2 divided by 1/2, which is 1. No big deal there. But let's look at my directrix. And my directrix, and this is where it helps for my Ika. My directrix, if you look at this, this is going to be a squared over c. Okay, which means I'm going to have 1/2 squared over 1/2, which is going to give me 1/2. Okay. All right, so that's going to become valuable later on here. Now, one other thing that's going to be valuable here, and we got to make a note here, so let's start talking about this, is we need our total distance from the focus to the directrix. Okay, so total distance, let's say TD, would be my F plus my D. So in this case here, it's going to be 1/2 plus 1/2. So my total distance would be 1 unit. And that's going to come into play later. Okay, and by the way, there's no correlation to my Ika. So that just happened that way. So no correlation to your eccentricity. So don't think it's going to be the same. All right. Okay. So let's go on to ellipses now. Okay. So this one you probably didn't spend any time at all in Algebra 2. So, but we did do a little bit in Calc. So ellipses, you have x squared over a squared plus y squared over b squared equals 1. So basically, it's an equation of a circle. When a and b are not the same, it's not a circle anymore. So then it becomes an ellipse. So to find my foci, okay, or focus, if you're looking for more than one, is almost the same thing as a Pythagorean theorem, but it's b squared minus a squared, or a squared minus b squared. That depends on if b is greater than a, and this one would be a greater than b. So when you take the square root, you have to have a positive value. All right, so let's jump right in this graph one. So we have x squared over 25 plus y squared over 9 equals 1. So that means my a is 5 and b is 3. And my focus, c squared, would be 25 minus 9. So c would be plus and minus 4. And what would this look like? Okay, so since x is 5, so on my x-axis I've got 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. My y, 1, 2, 3. 1, 2, 3. And let's graph out. Ellipse. Okay, now my focus. So I have my focus would be negative 4, 0. My focus here would be 4, 0. Okay, so now notice a couple things happen here. My value is c and my value of a. So look at my eca. E equals c over a. So I have 4 over 5. So now look at my eccentricity is less than 1, which it should happen on an ellipse. Okay. Now my key thing is this also has a directrix, just like a problem. So my directrix, now that we have my eca, is again a squared over c. But now this time your a and c is not the same here. So what you have here is 5 squared over 4. So we have 25 fourths, which is approximately 6 1/4. So if you look at this, your directrix, there's 6 1/4 is here. So you have x equals 6 1/4. Now you could also do one on the other side. But you only have one, and that depends on which focus you want to stand on. Okay, so if I'm going to stand, and I'm going to graph this ellipse from standing on this point, this is the directrix I would use here. Now if I stand on the other focus at -4, then my directrix would be x equals negative 6 1/4. So it depends on which one I stand on. Now, another key thing here, and it'll come in play much later, my total distance. Total distance of my focus plus my directrix. So if you look at this to find my total distance, probably the best way would be just go 6 1/4 and minus 4 to get 2 1/4. It would be my total distance, and again we're going to be using that later, okay, to graph out and polar. All right, now if we do, let's say, a shift of this, so let's say we have a shift of an ellipse. How does that affect everything? Not much at all. So you have x minus 2 squared over 25 plus, let's say, y plus 3 squared over 9 equals 1. So notice the same equation as above. So your center would be just 2 comma negative 3. So find that point, and everything else is just a distance from my center. So if I went out, was it 5 units? It'd be 5 units on this value. So you add plus or minus 5. What are my y value? 3. So here, plus or minus 3 to draw my ellipse. So the shift laws apply to this. And you probably just go back up here and say, okay, here's my point, 2 comma 3, and then just move everything from there. Okay. So I'm not going to spend much time on that, just to show you that the shift laws apply, but it doesn't affect anything. All right, next one, hyperbolas. Hyperbola. So we have, in this case, x squared over a squared minus y squared over b squared equals 1. Now to find my foci, it's c squared equals a squared plus b squared. That looks familiar, doesn't it? So it doesn't matter what a and b is. But to help draw this out, there are called slant asymptotes. And unfortunately, we kind of bypass a lot of that in pre-calc because it was not on the AP exam. But basically, it's found by slope. And remember, your slope is your delta y or delta x, or in this case, b over a. Okay, so it's always your y value on top of your b value. So let's look at an example here. So if I have x squared over 4 minus y squared over 9 equals 1, my a is 2, my b is 3, my c value would be 4 plus 9, so c would be plus or minus the square root of 13. My slope would be delta y over delta x. My y value is 3, and my x value is 2, plus or minus. All right, so let's graph this out here. Okay, so first off, now since x is the positive one, it's going to wrap around the x. So I'm going to go out 2 units and left 2 units. I'm going to use my slant asymptotes, which is my slope. So I'm going to go out, or actually in this case go up 3, 1, 2, 3 over 2. And therefore we have this one. And therefore we have the negative slope. And all that does is kind of help us draw out the hyperbola. So, therefore, we have that. Okay. Okay, so now our focus, now square root of 13 is a little bit more than 2, so your focus here would be root 13 comma 0, And then you have another focus over here, negative root 13, 0. Okay. All right. So that's a quick sketch of it. So now let's get some other things. Let's get my ICA. So my ICA over CA. So notice the same letters here. We have root 13 over 2. But notice if you divide these two out, this is going to be greater than 1. And so to find where this is, let's find my directrix. So since my ICA is this, that means my directrix is a squared over c. So that would be 2 squared over root 13. And if you divide that out, I think it's 1.1. Okay, so therefore your directrix, and again, I'm going to use this as my point of graphing later on. 1.1 would be right here. So x equals 1.1. Okay. Now, my total distance of my focus plus my directrix. Okay, so basically it's going to be, what is it, root 13 would be my minus, what is it, 4 root 13. And I'll just leave it as that for now. But again, that's going to be a key thing here, knowing that total distance between those two values. Shift laws still applies. So if we did the same thing as the ellipse, just move it, or just say, hey, here's your, you come back here and say, here's my, wherever my point I shift to, everything else is just a distance from that value. So again, not a big issue for what we're doing. All right. Okay, one last thing is putting it into vertex form. We did this first semester, so I'll come back to this, and then we'll stop. So putting equations in vertex form. And what I mean by vertex form is the ability to graph it out. Okay, so if we have, let's say, a parabola or parabola. Now you usually can tell that this is a parabola because only one value is being squared, like so. All right, so let's go ahead and complete the square, but convert it into vertex form instead of solve for it. So cross that off. And I'm going to take the approach of how I do it in Algebra 2. I usually drop that off, set equals 0. Then I go x squared plus 4x plus blank equals negative 8 plus blank. Okay. Now to do this, I'm going to take half of 4, which is 2, and that's the part you got to square, which is 4. So these are the two pieces you got to have. So first off, I need to use this first. So I need to put 4 there and 4 there. Okay. Then the next piece here, the 2, is what goes inside. So basically all you have to do is go x, whatever this number is, inside the parentheses. So you have x plus 2 squared equals negative 4. Then move that over. X plus 2 squared plus 4. Drop the equal sign, bring back your y equals. And then you got your shifts. So you have your vertex shift of negative 2, 4. If I wanted to find my directrix, so use my distance of 1 over 4p. My scalar in this case is 1. So 1 over 4 times 1, so you have 1/4. And then I can go ahead and find my focus, directrix, and ICAs, and all that. Okay. So if you want to look at that, like I said, you could even maybe do a little cheating here and say, well, here is my parabola. And here's my point, and I just shift it and to say this is -2, 4. And therefore, this is going to be 4th unit up. So if you move to 4th unit this direction here, it'd be -2, 4 and 1/4. There's your focus, and so on and so on. Okay. All right, I'm going to go on to the next one here. So, next example. So what happens if you have a bigger scalar than 1? So let's say we have y equals 4x squared plus 8x plus 16. Okay, again, same thing, cross this off, set equal to 0. But you got to have a scalar of 1 here, so you have to divide everything by whatever numbers here. And what we have here is x squared plus 2x plus blank, and this would be -4 plus blank. Okay, so again, taking this number, half of that number, 1 squared is 1. So those are 2 values. So first, do this piece here, 1 and 1. And then come back to the next piece here, and all you have to do is put an x there. Inside the parentheses, you have x plus 1 squared equals -3. Move that back over, but you also at the same time, well, I'll do it in stages here. You have x plus 1 squared plus 3 equals 0, but you have to put the scalar back in, so we have to multiply by 4. So we have y equals 4x plus 1 squared plus 12. So basically you do have a shift of 12, not 3. So you have to remember your scalar, and therefore 2, if you find your distance of your focus and your directrix at 1/4p. Okay, now that would mean that you have 1/4 times that, so you have 1/16 is actually your distance to your focus and your directrix from your shift. Okay. All right. All right, so let's do one more example, and we'll call it quits. But let's do one in terms of hyperbola. So let's say we have 9x squared minus 72x minus 4y squared plus 8y plus 176, and it's not a function, so we're going to have to say equal to 0. So what you got to do here is do a little bit of grouping here. So first off, here is this group, and here is my other group. And 176, I'm going to bring it to the other side. So what I got to do here is divide by 9, but I can't do the other thing, and I just realized I forgot something. It's like, oh crap. When I move this value over here, I had to multiply it. Oh no, I'm good. Nope, we're good. I thought I made a mistake. I didn't. All right, so divide by 9. So you have 9, and then you have x minus 8x plus blank. Here, divide by -4. Okay, so what you have then outside, -4, and you have y squared minus 2y plus blank. Then you have -176. And I'm going to be out of room here, so plus blank. But I'm going to have to multiply this by 9, because that's what's the scalar over here. And then another one here, blank, and times it by -4 because of that value there. All right, so do the same process. Take -8, divide by 2, so you have -4 squared is 16. And then do the same thing. You take -2 divided by 2, -1 squared, which is 1. So that would mean then I'm going to put 16 here and 16 here. 1 here and 1 here. Cleaning this up now. this would be 9x minus 4 squared minus 4 y minus 1 squared, and over here this could be negative 36. Now all I have to do is to get this form to draw out, divide by negative 36. And what I have now is x minus 4 squared over negative 4. Here I have y minus 1 squared over 9 equals 1. But notice my negative happened there, so basically it's going to be switched here, so you have y minus 1 squared over 9 minus x minus 4 squared over 4 equals 1. So my a is 3, my b is 2. Now my slope, though, is still plus or minus 3/2. So it's delta y over delta x, okay, even though this got switched. My c squared equals 9 plus 4, or c equals square root of 13, plus or minus. So on my eca, I have square root of 13 over 3. So this is my a value, my one that's positive. Therefore, my directrix, which is a squared over c, so 9 over square root of 13, would be my directrix, and then the big piece would be then to find my total distance by subtracting those two values. Okay? Alright, we're going to take a break there, and we're ready to get into graphing using this information into polar. So how to utilize this, my total distance, all this, and how to do that. Alright.